Hello, welcome to the discussion on laws and exponents. This is Module 1, Lesson 2 for College Algebra and Trigonometry. So first, let's get to know some concepts about exponents. If you have any number, let's say a, and it is raised to the power 2, then that is actually equal to a times a. If you have a cube, that is simply a times a times a. And if you have a to the power 4, that is a times a times a times a. So in general, if you have any number raised to the power n, then that is a times a times a and so on. And this is done n times. So say you have 3 to the power 2. This is simply 3 times 3, or that is equal to 9. If you have 4 to the power 3, that is 4 times 4 times 4, and that is equal to 64. Now, if you have a to the power n, the letter a is what we call the base, and the letter n is what we call the exponent or the power. And we say a to the power n or a raised to n. So now let's get to know the rules or the laws that govern these exponents. Say you have two numbers which have the same bases a and a, and they have powers m and n. If we are going to multiply these two, then what we get is a to the power m plus n. Basically, we retain the same base, only the exponent changes wherein it becomes m plus n. Let's look at some examples. So say we want to multiply 2 to the power 3 and 2 to the power 6. Now we can expand this first, find out what these numbers are, and then do the multiplication. Or we can use the rules on exponent. So this one would get 2 to the power 3 plus 6 because the exponents are 3 and 6. So we have 3 plus 6, which is equal to 9. Now if we have x times x cubed, now notice if we do not write any exponent here, that is equal to 1. So x is actually x to the power 1. So when you multiply x times x cubed, what we have is x to the power 1 plus 3. So that is equal to x to the power 4. Another example, if we have y to the power negative 2 power 5, what we get is y to the power negative 2 plus 5, and negative 2 plus 5 is equal to 3, so the final answer is y cubed. Another example, let's say we are going to multiply 3xy squared and 2x squared y cubed. When we do multiplication, we will multiply those that are the same variables. So exponents will be paired together, the x's will be paired together, and the y's will be paired together. So what we will have is 3 times 2, x times x squared, y squared times y cubed. So that means we have 3 times 2 is 6, x times x squared, so that's x to the power 1 plus 2, y squared times y cubed, that's y to the power 2 plus 3, or simply 6x cubed, y to the power 5. Now let's have the power rule. If you have as an exponent and is raised again, what we get is simply a to the power the product of those two exponents. So again, if you have a to the power m and we raise that to the power, that is equal to a to the power m times n. Let's do some examples. So if you have a 3 cubed raised to the power 4, then that is equal to 3 raised to the power 3 times 4, or that is simply 3 to the power 12. If we have y to the power 5 raised to the power 2, that is equal to y to the power 5 times 2, or y to the power 10. Now let's look at the power of product law. If we have a product, let's say A times B, and you raise that to the power n, we sort of distribute the power to both factors. So we get A to the power n times B to the power n. So if you have 4x raised to the power 2, you will be raising 4 to the power 2, and x is also raised to the power 2. 4 squared is simply 16, and we have x squared. So our final answer is 16x squared. If you have xy cubed, this whole product is raised to the power 4, then what we do is raise x to the power 4, raise to the power 3 times 4. And so we get x to the power 4 times y to the power 12. Another example. So let's say we have 4m squared n p cubed raised to the power 3. We raise 4 to the power 3 and raised to the power 3, so we get m to the power 2 times 3. N is raised to the power 3. P cubed is raised to the power 3, so we get p to the power 3 times 3. We do the multiplication, and we also get 4 cubed. 4 cubed is equal to 64. And then m to the power 2 times 3, so that's m to the power 6. Then we get n cubed, and then p to the power 3 times 3, so that's p to the power 9. The next rule is called the power of quotient. So if you have a fraction, a rational expression, or simply a quotient, and that is raised to the power n, then the same thing, we distribute the power to both the numerator and the denominator. For example, if you have 1/2 raised to the power 2, you raise the numerator to the power 2 and the denominator to power 2, so you get 1 squared over 2 squared. 1 squared, of course, is 1. 2 squared is equal to 4. Now notice 1/2 to the power squared, that's equal to 1/2 times 1/2. So that is equal to 1 over 2 times 2, that is 4. You get the same answer. Next example, let's say we have x squared over 3y, and this whole thing is raised to the power 4. So we raise x squared to the power 4 and 3y to the power 4. Notice 3y, need to apply the product rule. So x to the power 2 times 4, that will become x to the power 8. And 3y, again, we need to use the product rule, or the power of a product. So that becomes 3 to the power 4, y to the power 4. And then we calculate 3 to the power 4. So our final answer is x to the power 8 over 81 y to the power 4. Another example, if we have 4x to the power 4 z all over y cubed and raise this to the power 3. So again, we distribute 3 to everything, to all of the factors. So 4 has to be raised to the power 3. X to the power 4 has to be raised to the power 3, and then z to the power 3 is raised to the power 3, and y cubed is also raised to the power 3. So 4 cubed, that is again 64. X to the power 4 times 3, that's x to the power 12. Then we have z cubed all over y to the power 9. Now when we are dealing with negative exponents, by convention, it is agreed upon that we do not use negative exponents. What we want to use are positive exponents. So if we have a to the negative n, that is equal to 1 over a to the n. And similarly, if we have 1 over a to the negative n, then this is equal to a to the power n. So let's say we have m to the power negative 2. So this has to become 1 over m squared. And if you have 1 over z to the power negative 4, then this is equal to z to the power 4. Now let's say we have x cubed y to the power negative 2. So this is equal to x cubed times 1 over y squared, or simply x cubed over y squared. Now let's say you have a to the power negative 4 times b to the power 5, c to the power 3, d to the power negative 2. So a here has to be transferred. We simply think of transferring it to the denominator, and d has to be transferred to the numerator. So what we get is b to the power 5, d squared, a to the power 4, c cubed. So we have gotten rid of all the negative exponents and turned them into positive exponents. So that is the shortcut of sorts. If you see a negative exponent, you can just transfer it. If it's in the numerator, then it will go to the denominator, and vice versa. If it's in the denominator, then it goes into the numerator. So let's look now at the quotient law. If you have two variables with the same basis and they are being divided, and let's say the numerator has exponent m, denominator has exponent n, then what we get is a to the power m minus n. Recall, for multiplication it was a to the power m plus n, so if we are doing division, then that is a to the power m minus n. But take note, we cannot use 0 for this. More explanation on that on another video. So let's look at some examples. So what will happen if we divide x cubed by x squared? So that is x to the power 3 minus 2. So of course 3 minus 2 is 1. So what we simply get is x. If we have r to the power 4 divided by r to the power 7, we get r to the power 4 minus 7. Now 4 minus 7, this is negative. We have negative. We need to take note that we need to apply the rule on negative exponents. We have to make this a positive exponent, so that now becomes 1 over r cubed. Now let's say we have 3 times z4 over 6z4. So what will happen here? It would be easier if you would sort of coefficient and then treat the variable separately. So we will have 3 over 6 times z to the power 4 minus 4. Now 3 over 6 can be simplified as 1/2. And z to the power 4 minus 4, that's a z to the power 0. And again, any number raised to the power 0 is equal to 1. So 1/2 times 1, that is simply equal to 1/2. Now say you have 4w to the power 4, x to the power 3y all over 2w x to the power 5 times y. So again, we will dissociate the coefficient. And then we will have w to the power 4 minus 1, x to the power 3 minus 5, y to the power 1 minus 1. So 4 over 2, that is simply equal to 2. W to the power 4 minus 1, so that's w cubed. x to the power 3 minus 5, that becomes x to the power negative 2, and y to the power 1 minus 1 is y to the power 0. So again, y to the power 0 here will become 1, and we need to the power negative 2, a positive exponent, so that becomes a denominator. So what we get is 2w cubed over x squared. So far, the exponents that we have encountered are integral exponents, or those that are integers. So what would happen if we have an exponent that is a fraction? So say we have a to the power m over n. This is simply equal to the nth root of a to the m, or also equal to the nth root of a raised to the power m. For example, if we have 8 to the power 2/3, this is simply equal to the cube root of 8 squared. Now 8 squared here is equal to 64, and the cube root of 64 is equal to 4. Note that we cannot always get a perfect cube or a perfect square for whatever the case may be. So sometimes we would have to leave it as a rational, or as a radical. Suppose we have v to the power 4 over 5, then this is simply equal to the fifth root of v to the power 4. Let us now look at some examples of algebraic expressions that have to be simplified. Now, when we simplify, we need to have only a single base, and its exponents must either be positive or non-fractional. So what we must have are only positive exponents, and they must be integers. So let's say we have this algebraic expression. We want to multiply negative 5m cubed and p squared, and this whole thing is raised to the power 2 and multiplied to 2mn p squared. So first, because we are raising this to the power 2, we need to distribute first the power 2 to each of the factors. So what we'll have is negative 5 raised to the power 2, m cubed n raised to the power 2, and we copy the second factor, and then we simplify. So negative 5 squared, so that's negative 5 times negative 5, it becomes positive 25. M to the power 6 n squared p to the power 4 multiplied to 2m n p squared. At this point, we will now pair up those that have similar bases. So the code we have. Then we would have m to the power 6 times n squared times n, p to the power 4 times p squared. So what we get, 25 times 2, that is equal to 50. m to the power 6 times m will become m to the power 6 plus 1. N squared times n becomes n to the power 2 plus 1. And then p to the power 4 times p squared will become p to the power 4 plus 2. Further simplifying, we get 50 m to the power 7, n cubed p to the power 6. Next example, let's say we have 12x cubed y to the power negative 2 times z to the power 8 all over x squared y squared z to the negative 4, and the whole denominator is raised to the power negative 3. So again, we need first to distribute to this whole. So we copy first the numerator, and then the denominator will now become x squared raised to the power negative 3, y squared raised to the power negative 3, z to the negative 4 raised to negative 3. So we still have the same numerator, and the denominator will now become x to the negative 6, y to the negative 6, z to the power 12. Then we do the division. So 12, there's no constant in the denominator, so it remains as 2. X now will have 3 minus negative 6, or that is simply 3. Y will have negative 2 minus negative 6, so that is negative 2 plus 6. And 8 minus 12 is the exponent of z. So adding the exponents, we will get 12 x to the power 9, y to the power 4, z to the power negative 4. But we do not stop here because again, we have still a negative exponent. So that will become 12x to the power 9, y to the power 4. And then we will have on the denominator z to the power 4. Let's have the next example. So this time we have a quotient raised to a power 3. Because we have here a quotient raised to the power 3, we need to find first this quotient. We need to do the division first. In contrast with the previous example, only the denominator was being raised to a certain power, so we need to apply the power rule on it first and then do the division. This time we do the division first and then apply the power rule. So what we will get is negative 3 over 9, a negative to the power negative 4 minus 7, b to the power 4 minus 4. Now d and c don't have partners, so we sort of just rewrite them. So we just have d to the power negative 2 over c. So negative 3 over 9 can be simplified as negative 1/3. So a will now have the exponent, while b will have exponent 0. And then for d, because d had a negative exponent, it's transferred to the denominator. When we transfer, it's basically division. So when you divide, it does not become 0. So this is not blank. We write here 1. So we can think of this as negative 1/3. A to the power negative 11 is 1 over a to the power 11. And then we still copy 1 over cd squared. And all of these will have to be raised to the power 3. So what we have here, so we simplify first. Times 1, that's negative 1. Then when we raise that to the power 3, negative 1 times negative 1 times negative 1, of course, that is still negative 1. So that's why we have a negative 1 on the numerator. And then we raise 3 to the power 3, a to the power 11 to the power 3, c to the power 3, d squared to the power 3. So finally, we get negative 1 all over 27a to the power 33, c cubed, d to the power 6. Let's move on to the next example. So this time we have 2m squared n to the power negative 3p. Multiply it to the quotient 3mp squared all over 4n squared p to the negative 4. So we will simplify first this quotient. We will do the division on that. So copy first this factor. So we get 3 over 4. M doesn't have a partner, so it has a partner. So that will be p raised to the power 2 plus 4 all over 1 over n squared. So again, copy this factor. We simplify this as 3 over 4m p to the power 6, 1 over n squared. So we write this now as just a single fraction, so that is rewritten as 3mp6 all over 4n squared. So this time, we only have one letter or one variable or one base each on the numerator and the denominator. So we can now multiply that to this factor, to the first factor. So we multiply 2m squared n to the power negative 3p, multiply that to the power 6 all over 4n squared. So now we pair off those that have similar bases. So for the constants, we have all over 4. M squared is paired with m, n to the is paired with n squared, and p is paired with p to the power 6. So what we get, 2 times 3, that's 6 over 4. 6 and 4 are both divisible by 2. So we get, oh, this should be 3 over 2. Sorry for that. So that will now become m to the power 2 plus 1, n to the power negative 3 minus 2, p to the power 1 plus 6, or that is 3 over 2, m cubed, n to the power negative 5, p7. We still have a negative exponent, so we simplify that further. So what we'll get, m squared p to the power 7 all over 2 n to the power 5. Another example, let's say we want to multiply this quotient times this quotient, but this quotient is raised to the power negative 1. So what we will have is 5xy squared all over negative 3yz to the negative 2. And then this quotient 9x to the negative 1z all over 25x squared y to the negative 3z is raised to the power negative 1. So we do first the division on this. We also do the division on this second factor. So on the first factor, we will get negative 5 over 3y to the power 2 minus 1 over 1 over z to the power negative 2. Again, we do this because z does not have a partner. For the second factor, we have 9 over 25x to the power negative 1 minus 2, z to the power 1 minus 1, and y does not have a partner, so we just write it as 1 over y to the negative 3, and then this whole thing is raised to the power negative 1. So when we simplify, we will get negative 5 over 3x y to the negative 1, 1 over z to the power negative 2. Multiply that to 9 over 25x to the power negative 3, z to the power 0, 1 over y to the power negative 3. Then again, this whole thing is still being raised to the power negative 1. Further simplifying, we will get negative 5 over 3x. And then the negative exponent of y will make it 1 over y, and then the negative exponent of z will make it the z squared. And then also for the second factor, the negative exponent of x will make it x cubed, and the negative exponent of y will make it y cubed. So further simplify, all those that are in the numerator are put together, so we get negative 5x squared over 3y, and then the second one will have 9y cubed over 25x cubed. But again, still this is raised to the power negative 1. So when we apply the power negative 1, all this will have a negative exponent. This one will become negative 3. This is 25 to the power negative 1. This is to the power negative 3. So it is literally will allow us to just flip them from the numerator to the denominator, and from the denominator into the numerator. So just take a look. The denominator is now the numerator, and the numerator is now the denominator. So we can now proceed to multiplying this two. So we'll have negative 5 times 25 x multiplied to x cubed. Z squared does not have a partner. And then we have 3 times 9y times y cubed. So negative 5 times 25, that's negative 125. X times x cubed, that will give us x to the power 4. And then z squared is retained. All over 3 times 9, that's 27. And that's y times y cubed is equal to y to the power 4. The succeeding examples will now be using a sort of shortcut. We will not be showing the process of adding or subtracting the or multiplying the exponents. So we will just immediately do the addition, subtraction, or multiplication as the case may be. So let's say we have this 7wx to the power 4y to the power negative 3z cubed, and that whole factor is raised to the power negative 2, and then we have 2b squared xyz to the power negative 2. These two are multiplied. So we apply the power negative 2. We distribute it to each of the factors here. So 7 will now have a power negative 2. W has a power negative 2. X will have power negative 8 since that's 4 times negative 2. Y will have a power 6 since that's negative 3 times negative 2. And Z will have power negative 6 since that's 3 times negative 2. And then we will not yet be putting this into a denominator. It would be faster if we would first do the multiplication. So we will have 7 to the power negative 2 is 1 over 49. So if we pair the constants, we will have 2 over 49. And then v squared does not have a partner, so we just write here v squared. W does not have a partner, so we also just write w to the negative 2. X, on the other hand, has a partner, so we have x to the power negative 8 times x, so that's negative 8 plus 1, so that's to the power negative 7. Y has a partner here, so we have y to the power 6 times y, so that's 6 plus 1, so that's 7 also. And then z has negative 2, so negative 6 plus negative 2 is negative 8. So what we want to do now is to simply change the negative numerators into positive by making them denominators. So those that have positive exponents, so we have 2 v squared y to the power 7, and the denominator would have 49 w squared x to the power 7 z to the power 8. Another example, let's say we have this quotient 5m to the power 4n to the power negative 2 p cubed all over 2m to the negative 2 n squared p to the power negative 3. The denominator here is being raised to the power negative 3. So again, we need to do exponent on the denominator. So we copy the numerator, and then the denominator would have 2 to the power negative 3. M will now have 6 because that's negative 2 times negative 3. N will have negative 6, so again that's 2 times negative 3, and then P will have power 9. Then we do the division. So remember here 2 has a negative exponent, so we make it into a positive exponent. It now goes into the numerator. So what we have is effectively multiplication of 5 and 2 cubed. So for m, we have 4 minus 6. So 4 minus 6, that's equal to negative 2. For n, we have negative 2 minus 6, or minus negative 6. So negative 2 minus negative 6 is just like negative 2 plus 6. While p would have 3 minus 9. So that's 9. So we simplify that further. 2 cubed, that's 8. Oh, this should just have been 40. So 40, only n has a positive exponent, so that remains in the numerator. And then for the denominator, that's m squared p to the power 6. Now let's say we have this quotient raised to this exponent. So 5a to the power 5, b to the power negative 4, d to the power negative 2, all over 20, a to the power negative 7, b4, c. So 5 divided by 20, that is equal to 1/4. A to the power 5 minus negative 7, so that's 5 plus 7, so that is B would have negative 4 minus 4, so that is negative 8. For D, we have no partner, so it still remains as negative 2, and C also does not have a partner, so we retain that as 1 over C, and then the whole thing is raised to the power negative 2. So only A here is an exponent and has a positive exponent. A is in the numerator and has a positive exponent, so it is retained in the numerator. Everything else is in the denominator. So on the denominator, we have 4b to the power 8 d squared times c. And then now we distribute the negative exponent. So when we put the negative exponent, we practically flip the numerator and the denominator and then raise everything to the power 2. So 4 raised to the power 2 is 16, b 8, b to the power 8 raised to 6 to the power 2 is b to the power 16, d to the power 2 raised to negative 2. So from the denominator it becomes numerator, as well as c becomes c squared, and then a becomes has now a power 24. Last example. So now let's say we have 2m to the power 3/4 n squared p to the negative 3. This is initially raised to the power 2 and then raised again to the power negative 3. So when we raise it to the power 2, we would get 4 m to the power 3 halves, because 3/4 times 2 will become 6 over 4, and both are divisible by 2, so that is 3 over 2. And then we would have n to the power 4, p to the power negative 6, and then again this whole thing is raised to the power negative 3, so we distribute the power negative 3 to each of the factors, so we will have 4 to the power negative 3. M will now have the power negative 9 over 2, N will have power negative 12, and P power negative 18. So we will now have the negative exponents in the denominator, and the positive exponents will remain in the numerator, which is only P. So on the numerator, we only have P to the power 18. 4 cubed, that is 64, but that's a negative exponent, so it's now in the denominator. N will now be on the denominator with power 12, and the m to the power negative 9 over 2 is equal to m to the power 9, and get the square root of that. For now, we will have the square root in the denominator, but in our succeeding lessons, we have rules on how to treat the radical expressions. That will be it for now. Have a good day, everyone. Keep safe.